There are a few concepts to learn in Chapter 9. During a reaction, the collision theory states that for two reactants to react, their molecules must collide with the correct orientation and sufficient energy. To recap, the rate of reaction is a measure of how fast a reaction processes. It is calculated by the change in amount of reactants divided by time. Activation energy is also an important number. It represents the minimum energy needed to process a successful collision. This is a graph of the enthalpy change of a typical exothermic reaction. The difference between the initial energy and the peak is the activation energy. Catalysts are something we are familiar with in GCSE. It speeds up a reaction, but it's not changed or used up in the reaction. In A-level, catalysts are further categorized into homogeneous catalyst and heterogeneous catalyst. Homogeneous catalyst is a catalyst that is in the same phase as the reactants. For example, the catalyst dissolves while the reactants are aqueous in the solution as well. Heterogeneous catalyst is the opposite of homogeneous catalyst. It is in a different phase as the reactants. Commonly, heterogeneous catalysts speeds up reactions with gaseous reactants. There are also another kind of special catalysts, which are enzymes, or also known as biological catalysts. As the adjective suggests, they are much more complex than non-biological catalysts as they are all proteins. Typically, enzymes provide alternate solutions to a same reaction with lower activation energy. There are significant differences between enzymes and regular catalysts. They are much more efficient, usually speeding up a reaction by a base of 10 to the 6th to 10 to the 12th times faster. They are also much more specific. Usually one type of enzyme only catalyzes one reaction. And due to their specificity, they do not produce additional byproducts. In comparison to other catalysts, enzymes work in a more mild condition, usually 37 degrees at atmospheric pressure. It can also be regulated inside a cell. And if the temperature becomes too high, enzyme denatures, which meant that it will no longer speed up the reaction at its normal rate. Speaking of temperature, it has a significant impact on rate of reaction. As we have learned before, the higher the temperature of the reactants, the faster the reaction. However, temperature is not the direct cause of increasing the rate of reaction. This is because particles may not process the same amount of energy as other particles. The Boltzmann distribution describes how unevenly are energy distributed amongst particles. It is a general distribution at a certain temperature, with the x-axis the molecular energy and the y-axis the number of moles of particles with this amount of molecular energy. This is where the activation energy is at. And the shaded portion of particles that has a molecular energy which is higher than the activation energy are the particles that actually react. This is how the graph looks like when the temperature increases. The distribution of particles are more even and more particles have sufficient energy to react. We can conclude through these graphs that the rate of reaction increase because temperature increase results in a bigger portion of particles having more molecular energy than the activation energy. This is all for this video. Thank you for watching and subscribe for more A-Level Chemistry videos.